Here we're going to compare the variation between two sets of data, and the correct measure of variation to do that is the coefficient of variation. They do mention that there is one occasion where it's okay to actually compare standard deviations, and that's in the apples to apples case, where your data is same units, has about the same mean, but you will never go wrong using the coefficient of variation to compare the two data sets. And when we do this, this is going to be an eyeball test in terms of, are they close enough or are they different enough? And what we're going to use as our measure for that is when we take the differences of the coefficient of variation, if it's greater than 5, then that's large enough to say that they're different. If it's less than 5, then it's not different enough for us to go ahead and say that the variation between the two data sets appears to be different. And again, we're making an inference about what's going on with the population. So, I mean, if the coefficients of variation aren't exactly equal, then yes, the sample variations are different, but we're talking about what's going on with the populations. So, taking a look at 21, they ask us to compare the variation of the systolic and diastolic blood pressure readings. And to do that, the best way to get the coefficients of variation is to make use of technology. So I typed in all of the data for each. And for each of these, we're just going to right-click on the column and do the Explore column. And in StatDisk, it's labeled coefficient of variance. And they said the way to round this out is 1 decimal place. It should be a percentage. It should be 1 decimal place. So the coefficient of variation for the systolic reading is 14.6%. Now, if we want to go ahead and change that over to diastolic, we get 16.9%. So the coefficient of variation diastolic, 16.9%. And if we're to take 16.9 and subtract 14.6, we get 2.3. 2.3 is less than 5. So there's not enough of a difference in the coefficient of variations for us to say that the variation is different between these two populations. So we would say that the variation is roughly the same. Taking a look at another case down here with the bank queues. So we have two setups. There's the top setup where everybody gets in a single line and goes to the next available teller. And then there's the individual lines where each teller has their own line. And they want us, again, to compare the variation of these two populations. So type in the data, and we'll run it for the single line. And we get, well, that's not going to cooperate. So the coefficient of variation for the single line is 6.7%, and the coefficient of variation for the individual line is 25.5%. And when we take the 25.5 and subtract 6.7, this is obviously going to be greater than 5. So that's 18.8 greater than 5. So here we would say that there is a difference in the variation between line setups. Back up here, we would say the variation is roughly the same.